Hello. In this video, I want to explain how a banked slope helps a car make a sharp turn. Let's start with a car on a level road. Let's say this car is trying to make a left turn, which means this car needs a centripetal force towards the left. And this force cannot be provided by the weight or the normal contact force because these are vertical forces. So the centripetal force must come from the frictional force. That's the road surface exerts on the tires. So if you want to turn more sharply, you can use better tires with better grips so that you get a larger friction. But that's about all you can do. So how does a banked slope help? First, notice that the normal contact force is no longer vertical, it's slanted, and therefore it can provide a horizontal component in the centripetal direction. If the angle of inclination is theta, then the normal contact force also makes the same angle theta with the vertical, which makes the vertical components of the normal contact force n cosine theta and the horizontal component n sine theta. So vertically the net force should be 0, so the upward n cosine theta is equals to the downward mg. Horizontally the net force is of course the centripetal force, so n sine theta is equals to m times v squared over r. So take this equation, divide by this equation, we get this expression again, tangent theta is v squared over rg. So basically by using a banked curve, we are relying on the normal contact force instead of the frictional force to provide the required centripetal force. And there's actually no limit to how big a normal contact force is compared to friction, as long as the banked curve does not collapse. In fact, if you want to make a sharper turn, you just have to increase the angle theta. Okay, that's all. Ta-ta!